Hi, this is Bill Foote, and this is part two of week 7, decision making with spreadsheets. Yeah, decision modeling, or making the decision is a much different deal. Decision modeling with spreadsheets, and we're kind of at the end of our rope here for this segment of material. We have in front of us right here the end that we seek, a spreadsheet model that models the amount of capital in year 1 needed to provide funds for workers' comp claim experience. Now that whole forecasting exercise was performed in week 6. But what we want to do here is do exactly what we did there and reverse engineer. It's more of a forensic move. So this is the picture that we get. Okay, where did this picture come from, and so on. And that's the purpose of this particular video. Well, capital 1 comes from somewheres. There we go. Oh, that comes from someplace called EDA Sim, long short term. Okay, where is EDA Sim, long short term? Oh, it comes from this very one right here. Okay, comes from right here. And that in turn comes from year 1. This one right here. So apparently we have the choice again, year 1, year 2, up to year 6. So we amount of capital there. You can see that's pretty big. Or year 5. And we can get a grid. And why do we want to make a grid? Well, we might want to, let's just go back to this. You might want to, for example, let's look at the blue curve and ask the question, where does it come from? If we do that, we go up here to chart design in the ribbon, select data, use my favorite, oh, there we go. Relative frequency is where that comes from. Let's edit that, just look at it. We'll see where it comes from. The name of it actually comes from L. There we go. The X values actually come from something else over here. We have a ref there we have to worry about. That's probably the midpoint. And the Y values come from L again. Okay. Now, notice that we have pretty small values, 0.7 in one case, all the way up to, in another case, 0.1. Okay, so this is just looking back from here and asking the question, where did these series come from? Well, they came from this graph and from this table. Okay. Here are the values on the x-axis, the abscissa. You can see the frequency here, lots of frequency again, as we experienced in week 6, lecture 6, with the extreme value distributions. Lots of values that center around 155,000. And then they precipitously drop off. But then they, interestingly, come back over here. Okay, a little bit of a bathtub. We have the table generating 21 of these values, and also not just relative frequencies. Frequencies are just counts, but also cumulative relative frequencies, and a raw and a PDF GDP. Oh, interesting. That comes out as a ref. Wonder what that is. Where did this come from? Now we're just going to call this GPD CDF, the cumulative. Nope, we didn't want to do that. Get rid of this. Go back over here. There we go. GPD, generalized Pareto distribution, cumulative distribution function. There we go. Now we have something we can write home about. Cumulative relative frequency, another typo here. Well, that's a good way to show you that this is a very dynamic piece. That we want frequency. There we go. Now everything's hunky-dory again. We use count if functions here to produce this 68. And the question is, where does it come from? This indirective C50, C3. And C3 is the choice of claims year 5. So where are claims year 5? That's what we have to look at. Claims year 5. Down here. Okay, and they're over here. Claims year 5. They're in some larger thing called a fun simulation. And so we obviously had done a fun simulation. Oh, we did the fun simulation and then looked at the exploratory data analysis of that, which included, again, a phenomenological look at the simulation. How do they appear? The visualization. Not just the tabulation, but the visualization as well. Okay. We have a lot of other things here as well. These are the actual allocations. What for 1 to 2, 2 to 3, 3 to 4. B is 3 to 5, that's the 2-year one. 4 to 7, 3-year one. Another 1-year one, and so on. So we have different allocations, and that's kind of interesting to look at. Uniformly, this model does not like these B. Doesn't like B. No, it likes B once. There we go. And it likes C once, but doesn't it like? It doesn't like D, the longest term possible funding vehicle. Okay, so we did simulations here. And where did these simulations come from? Well, they came from here. Recorded. One simulation was produced here, and then it was recorded here. And then the spreadsheet ran again, another one, and it's deposited here and then recorded here, and so on all the way down. I wonder what the last one looks like. 1733. No, the last one is not recorded because we only went up to 100. If we had gone to 101, it would have been recorded. Okay, that was the very next one, literally on deck. This whole piece here is called the interface. You can see it's called the interface. That's its name. This whole piece is row 0, called simulation, just like we did before. Okay, and now where do these things come from? Where did this come from? It came from fund allocation E29. So here's the fund, oops, let's get rid of that. The fund allocator itself. There we go. Now we're back to the core model that's being worked on here. As we can see, this model has inputs from something called fund claims. A, B, C, D. Okay, fund claims. Guess the rest of it is hard-coded in here. Yeah, hard-coded. That looks like it was solved for. All those digits. This also is an input from fund claims, the return itself. This is a per period return. And that's just calculated off of the first one. We have that. That's calculated. Now, this is due to Cliff Ragsdale, his code for putting this together, which is a very good example of if, and the and function. Okay, it's good to unpack this. Okay, if this is an intermediate one like this, look at what you pull up. Otherwise, you put in a blank like this. Okay, and there are other aspects of this. 1 plus F8. What is the 1 plus F8? Here's F. Here's that. Put in a 1 plus F8. Oh, that must be this one here. Yeah, 1 plus F8. Okay, gives you the return per dollar. The return, you get $1 plus an amount of money, right? The total return. Okay, these are going to be multiplied, by the way, cross-multiplied by these numbers, the actual capital needed. This gives you the entire return schedule laid out over time. Okay, and that's pretty useful right there. What is this? Sum product of two things, an H column and an E column. Okay, the E column is this capital column. The H column is, this column right here. So it's basically saying in year one, okay, you're only looking at flows starting in year one. So it's going to be just these items right here. Okay. And actually, this is at year two. Year one is here. And year two is the result of actions in year one. Nothing going on here, because if you did have an allocation here, which you don't, we'd get it to year three, and this one year four, and this one year seven, which doesn't seem to be firing up at all. That's a zero. Okay. So that's the sum product there. Where did this come from? This came from, oh my gosh, this is looks like it was pasted and copied in. Pasted and copied in from where? Let's see if we can find that where. Fund claims. Probably here. Okay. Going to be interesting to see where this stuff comes from. Here's the original data itself, the entire piece. In fact, to do this correctly, we probably would have wanted, say, this is equal to that, because that's the data referential integrity issue. There we go. Ruining my formatting for the moment. Okay, and then these come in directly from fund claims too. Here's that fund claim, and then that return as well gets deposited in there. But what about these? Okay. Now we have sigma here, and we have a claims sigma. Oh, down here, there we go. Cut and paste into the fund allocation constraint. Now, apparently this model, for it to work, and for solver, which is the thing that we're going to go right back to, for that to work, to do this properly, you usually have to do a cut and paste operation from prior pieces to make it work continuously and without any problems. Okay, and if we want to look at that cut and paste operation, let's go to Developer Ribbon Visual Basic. And here's the solve capital piece. Yes. And this is actually doing the selection of the copy and the paste. Here's the copy and paste right here. This is all in one fell swoop, where we are going into the C Sigma Sim sheet, select that sheet, and while in that sheet, select a range. And the range here is Y4 to Y9. Well, if you change the range in the sheet, you're going to be in trouble, so don't change it. Y4 to Y9. Oh, that's an interesting model for another time. Very interesting model, actually. Okay. Here is Y4 to Y9. Here it is. Y4 to Y9. That's what it's selecting, actually. Looks like somebody cleaned this up and made it nice and neat without too many extra things. So take this, Y4 to Y9. Let's go back to oh no, we don't want to look at this. Oh, this is actually very good. Again, another model. Y4 to Y9, back to Visual Basic. We got to go to the model that we need to look at. 7 claims. There we go. Looks like a third iteration. Y4 to Y9, select that, copy it. Okay, then go to the fund allocation sheet, select the range there, and paste special with transpose. So take that column and make it a row. Take the column and transpose it into a row. Okay, that's kind of cool. Now, where is that? Fund selection, J20, 020. Let's see where that is. So we go from here. Fund claims. No. Fund allocation or fund simulation. B and 4. I don't know where it is. Let's find out where it is. I guess it's fund allocation. Okay, let's find out where that is. Let's go back into the so it's in the fund allocation sheet. at J20 to O20. It should work. Let's see what is in there. This is part of the hunt and peck method. Fun allocation J. J20, O20. So where's J? J20. That would be down here. O20. No, that can't be correct. So apparently that particular routine isn't working in this particular model. What routine might be? No, we need to find that out. We have a one-time run here. We have an allocator several times. Oh, okay, let's see what is going on. That's the business of forensic modeling. So it isn't apparently this, which looks really good. I would probably use this and put this in the correct spot. Notice it's a transpose. That's really good too. Okay, so where might this be? Oh, it's probably this one. Ooh, transpose false. Oh, it's going somewhere else. Okay, let's check this out. Still C, sigma, sim. Go to E15, select it. Select whole thing there, do a copy, go into fund allocation, range, paste, no transpose there. Let's see if we can follow those pieces. At, what is it? H20. Well, that looks like the correct one. So it looks like somebody was trying to develop, actually, a alternative approach that's a little bit cleaner. Okay, yes. And that's hacking through the forest here. Let's check this. And then it does a solver, okay, with models, okay, and it's changing things. Oh, okay, cool. And then after that, it's going to run the Monte Carlo. Okay. It's going to take something from the fund allocation that was run one time, pop it into the Monte Carlo, and then do this whole thing 100 times. Fascinating. Okay, got it. So here's the H to the M, and that's what gets copied and pasted values in there. Okay, so we got that. So let's just run this, see if it even works. Run one time. Yep, it seemed to work. Okay, keep getting this answer. Good. Then we can run 100 times, which I really don't want to do. Okay, not at this moment anyways. And here is the basic model. Minimize the amount of capital invested, that's in E19, by changing E7 to E, it's a variable cell, by changing those allocations subject to G, at the constraint cell, equal to a requirement cell, such that all of the allocations are positive. No short selling in this model. It'd be interesting to see if you do a short sell in this model. Yes, that would be another strategy involved. I see some names were produced down here, okay, in order to get the different allocations, and capital year one. Okay. Here's a transpose of E19, which we could possibly use. Here's a copy and paste values to the some, oh, this is what we want. This is the piece that is brought over to the simulation. There we go, E29. Okay, so every single time this solver runs and has an optimal value, here are all the optimal values, and then we put together the claims experience, okay, against the allocation, we get a surplus. These are all the cash flow surpluses. Okay. And then we do this 100 times. There we go. That's the model. And again, the next round of this modeling experience will be probably changing that VBA to be a little bit cleaner. Okay, again, the funds claim and our original correlated C and sigma. C tells you how uncertain, sigma tells you how much variability there is, and this is a lovely combination of two things that is used in leave one out integrated cross-validation and machine learning. So that's kind of cool that we're doing a machine learning simulation and building it into a optimization model and then running the Monte Carlo in order to generate what the allocation forecast would be, the optimal allocation forecast. Okay. Remember, with a max claim. Okay, let's get back to controls. The only controls here are a list of the simulations that one could pick should one want to do that. Here's the EDA, and that comes up in this list. So if we go back to the year one number, there's a max, a min, and that generates, again, the intervals. We have a begin, we have an end, we have a mid, and the count ifs are two conditions, logical conditions on begin and end. You get 78 this particular time. And the rest of it is just arithmetic to get us to draw these graphs. Okay. Now, if we wanted to do a short run version of this, what would we do? Very quickly, go to fund claims. Okay. Use only A, this A, this A, this A, and this A, and set everything, all the returns to 0 for the other vehicles. That should do it. Try it. And you'll have a totally different experience, and you will have your second scenario. Now compare and contrast. Which one are you going to choose? So the A answer is an explanation of all of the phenomena that you see here, but the A answer really is, on top of that, what are you going to choose and why? Okay, that's the key. That's the key. And as shown in the example in the book, chapter 10, you have a big choice between the two. Well, now it's time to come to the table and say, which one would you choose and why? Okay, the choice is ontological, the way you're going to choose epistemological, all based upon the phenomenology of this whole model. Anyways, sprinkling a little bit of philosophy in it can be a very dangerous thing. Want to leave you with this, and hope you enjoy the show, and happy modeling. And again, thank you very much for your kind attention throughout this process. Take care.